Hi, welcome back. So last time we talked about the arrange function, and I gave you some examples of why we should be writing code in a pipeline. I'm hoping that I don't have to sort of quote unquote beat that dead horse. I'm hoping that you really are understanding now why using the pipe operator is important and why writing your code in a flexible and extendable pipeline is the proper way to do reproducible data science. So I know that it may be very strange for you to see this symbol all through this code, but I hope that I've convinced you by now why it's important, why it's valuable, and why it makes your code easier to read and easier to go back and check and edit and update and extend later. So now for the select command. Now, you may be thinking, all right, this is basically, if I've got Microsoft Excel open, this is cut this column, insert this column somewhere else. Um, it doesn't sound like that's going to be super important, um, but I want you to think about one of the reasons why this is written as a function. And that is sometimes you end up with data sets that are too large for your computer to actually open, especially Microsoft Excel. Microsoft Excel has memory limits. Microsoft Excel has limits on how many rows and columns you can have, whereas your computer it's sort of limited by how much space you have on your hard disk and how much space you have in RAM, but you can even move beyond that and work in databases that don't actually load the data into memory. And you get even more flexibility. So you could very quickly be working with a large medical database that you're never going to actually load all of the data into memory on your computer. You're never even going to have access to all of the data. But the same commands that you're learning here to work with these very large data sets, working with a small data set like the flights data set, will work on these huge, massive data sets with tens of billions of records if you have something like that. I have a friend of mine that works for a bank, and they have a record every single time your credit card gets charged. So if you're banking with this particular company and you swipe your debit card or swipe your credit card, that becomes a record in their database. They have trillions of records. They're using the exact same functions here. Now, maybe they're using it in a different language. They may be perhaps using the select function out of SQL instead of the select function in R or RStudio. But the idea is the same. They're using the same filter commands. They're using the same arrange commands. They're using the same select, the mutates, the groups, the joins, all of the same stuff they're doing, but they're working on trillions of records and hundreds of thousands, if not millions of features. So understand that it's not just like, oh, well, I want to move this column from here to here. That's right click and cut and right click and insert the cut columns. We want to be able to write code that will allow us to work on data sets that are so far larger than anything that we could open in a laptop and the code still work. So anyway, this is what the select function is doing. It allows us to reorder. It allows us to extract columns and it allows us to remove columns. It also technically allows us to rename, but we'll get into that a little bit later. So let's say that we only want these three columns. We want the year, the month, and the day. Then I'm going to say, take the flights data set and then select the year, the month, and the day. You notice this reads like English almost. Once you get used to it, it reads the same way that you would talk about the command in English. Take the flights data set and then select the year, the month, and the day. It reads very similarly to English. That actually helps us later on when you go back to your code 6 months or a year later, you can kind of read what you're doing. Like, oh yeah, that's what I was doing. Um, but notice here, we got the columns that we explicitly requested and not a single one extra. So the select function will drop whatever we don't ask for by default, unless we add another function, and that's called the everything function. So we'll get into this a little bit later when we talk about reordering columns. So you can say, okay, I want to keep all of the columns in the data set. I just want to move these columns from one position to another. And that's where you can use the everything command. You can also specify instead of if I know that year, month, and day were in order in the data set, and I just want to pull out these, then I can say, give me everything from year to day. So take the flights data set and then select all the columns between year and day inclusive. This is super helpful because there are a lot of times where the CDC data sets they will have their column names are very structured sometimes. And so you can say, I want you to give me everything between this column and this other column, and you'll end up selecting like 60 different columns that are all related to this family of measurements. Um, it's really good anytime that somebody was given like an instrument. So for those of you that have taken a psychology course, you know that instruments, like the brief symptom inventory in addiction, or perhaps the Fagerstrom, there's a Fagerstrom measurement for nicotine dependence. There's all sorts of different instruments that you could give someone in psychology. And a lot of times when they're stored in the data in a database, they have the same like prefix for the column. So it'll be like Fagerstrom underscore question one underscore question two underscore. So they're all basically the exact same thing. So if you know what the column name is called, you can just say, okay, give me everything that's from Fagerstrom Q1 to Fagerstrom Q16 or something like that. There's another way to do that, and that's with the starts with command. And so you can say, give me all of the columns that start with Fagerstrom. So if you're looking for all of the features with that instrument, as long as they're named something consistent, and this goes back to a couple lessons ago when we talked about how important naming things are. If we've named our columns consistently, then you can say, okay, give me everything that belongs to this group of columns. And you just get to go in there and pull out these 40 or 50 columns, and you don't have to deal with the other 700 or 800 columns, and you're just working with the data that you care about. Um, so that's the starts with helper. And then you've also got the ends with helper. So let's say, for instance, if somebody had they did a different naming convention, and for whatever reason they said Q1 underscore Fagerstrom, Q2 underscore Fagerstrom, and then they put the name backwards for whatever reason, then you can go with the ends with. There was, so in the CDC, a lot of the like the American Community Survey data will have the last bit of that column, the last bit of that column name will say what kind of information was measured, whether or not it was a count, a proportion, or a margin of error, or something like that. So if you know that all of that, you only want the proportion data because it's giving the rates, then you can say, give me everything that ends with proportion. So underscore PROP or whatever it is. So these are helpful, very powerful helper functions for you to get at the data, the parts of the data that you really want to figure out. Um, this one right here, select all of the columns that contain time. So going back to our SNAP data example, if we wanted to find out, so we've got a whole bunch of measurements about the food stamps, SNAP data, Supplemental Nutrition Assistance Program. If we wanted to find something related to income or something related to ethnicity or something related to disability status, something related to whatever, and you're like, okay, well, I don't actually know what's in this data set. Say, okay, just give me any column that contains this keyword and we'll see what comes up. We'll see what's actually in this data set. A lot of times, if you're dealing with hundreds, if not thousands of columns, it's difficult to go through and figure out what each of the column is doing, what each columns are measuring. So you can just say, give me anything that has this word in the name. And then this one is super powerful, but honestly, very, very complicated. Find all of the columns that start with exactly 3 lowercase letters. So that's this bit right here. So this is a symbol that says the character string starts with. Then we say it starts with any of the lowercase letters. So I've got a square bracket that says anything in this set, and that's A to Z, but I'm giving you lowercase a to Z. And how many of them? I want exactly 3. And then the next symbol will be an underscore, but because the underscore is special, I have to put these backslashes in front of it to escape this. Now, this looks like some freaking craziness. This is actually called a regular expression. We're going to have an entire lesson on strings. This will be right here, wrangling character strings with the string R package. Um, the matches command, the matches helper function will take in a regular expression. And so I'm not going to talk so much about regular expressions right now. And even then, even when we go over the strings lesson in later on in the semester, I will not be able to thoroughly cover regular expressions. For one, I'm not an expert in regular expressions. I usually have to go to Google to get me to help, practice regular expressions almost every time that I use them. There are a couple that I have memorized that I can just kind of figure out what's going on, and I can read this regular expression to tell you what's going on. But there are a lot of regular expressions where I see in other people's codes, I look at it and I'm like, what is this doing? Oh my God, help me. So don't feel lost by this. This is one of those things that I struggle with to get good at regular expressions. I don't use them often enough, so I haven't built up that skill. However, we will cover this later on in the semester. There are some, there's this really cool website down here, the regular expressions website, where you can practice building regular expressions, and kind of check your regular expressions to make sure that they're doing what you think they're supposed to be doing before you use them in your code. Um, but for now, what I'm going to say is kind of stick with these simple ones where you just say, let's match to a word, and that's going to help you out a lot. These are very, very powerful as they are. This stuff, the regular expression stuff, is crazy powerful, but it takes a bit of learning to get used to it. So anyway, we'll cover more. We'll have some more time to do more homework problems on regular expressions once we get down to the strings chapter in a few lessons. So let's go ahead and stop there, and we'll pick back up with reordering and removing and renaming columns. Okay, see you soon.